Hey guys, this is Avon. I'm a coding tutor, and recently I interviewed with Amazon, the everything store. As many of you already know, the interview consists of four parts conducted by different people, sometimes two people at once. One is a system design part, and three of them are coding challenges. And with each part, there's also a part where they ask leadership principle questions. Everything was going well. The first part was a system design part. That's the one I was the most nervous about, but I did okay. I did good. The guy was very friendly, and I didn't get stuck. And I feel like I solved the problem to the satisfaction of the interviewer. Second part was a coding challenge. That one was a little bit tougher because it was two people, and one of them was just maybe incredibly uncomfortable. And it was just like he wasn't very friendly, so that kind of threw me off. But I did okay. I solved the problem at the end, and I felt like, and I was able to answer all the questions. Then came the third part. This lady came on, this wonderful woman. She was very friendly. We had a great small talk at the beginning, and finally she presented me with a challenge, and the challenge was declone a linked list that has random pointers. So right away I got happy and I was like, all right, this should be easy. I'm just going to iterate through the linked list and just create a copy as I go, right? So I started coding, talking about it, and then I realized all the challenges that come with a deep clone. And I was like, crap, And so long story short, for the next 45 minutes, it was just me basically doing a bunch of these. Yeah. Oh, can you help? Not sure. Maybe. It was just horrible, and so there was just I did really bad on that part. And then finally, the fourth part was another coding challenge where I thought I did well. The guy just was not very friendly, but he just wanted the answer of the coding challenge, asked me a bunch of other questions, and that's it. He kept it very short, and I thought I did okay on that. Well, anyway, so I wanted to go over the one that I couldn't solve. The one coding challenge just kicked my butt. The deep clone of a linked list with random pointers. So let's take a look at, an example of a linked list with random pointers and see if we can code it up. See if we can create a deep copy of it. All right, let's get to it. All right, so here we go. We have a linked list is an example of a linked list. It has 5 elements. The first one, this one right here, this would be the head, right? Oops, not that way. It's this way. So this would be the head. Let me see if I can type some text. I don't see that option. Yeah, so anyway, so this is the head. It's pointing to this one, then this one is pointing to this one, and so on. So you get the point. And then each one also can point to a random element anywhere in this list. So the first one can point to the third one, and the third one can actually point backwards too. So for example, right here, you'll see 10 is pointing to 11. Anyways, and then it also another thing that to take into consideration that a random doesn't have to be set, so it's possible for random to be null. So you can see here the first one is pointing to null, right here. Okay, so all right, let's just solve it. So for that, I'm just gonna pull up a let me see, a online compiler / editor, and actually I still have, okay, let's get rid of that, the arrows. Oops. Okay, and we're gonna use online GDB, and I'm gonna create 3 files. The first one is going to be main. The second one is going to be the solution. And the fourth one is going to be a single note. Okay? So in main, what we're going to do in the main method, because that's the one that's going to kick it off, I'm just going to copy what I have in my notes. Okay. So I'm creating a new solution object. I'm creating a bunch of notes. Each one of these notes is going to be representing the image that we were taking, that we saw right here, right? So simple, right? So node 0 is going to be this one right here. This is going to be node 0, node 1, node 2, and so on, right? And finally, I call on the function that actually does the clone, and what it does, it just returns the head node. So that would be this one, but I'm sorry, so that would be this one, but the copied version, right? Not the original one. So there's going to be an original linked list, and there's going to be a copy, right? All right, so let's, and then finally, I'm just printing out the new list just to make sure that I did everything correctly. So in the solution, I'm just gonna copy the beginning of the solution class definition and the function copy random list, right? And the way we're going to solve it is we're going to need 3 nodes. One is going to be the copy node. The other one is going to be the current node that we are iterating over, because we are going to iterate over the linked list, original linked list. And finally, we're going to have one node that keeps track of the previous node, and I'll explain why we need that. So the logic is that let me see if I get rid of it. Okay, so the logic is that, just give me 1 second, that we're going to go through this linked list, and as we go through it, we need to keep track of the previous previous node. So when we get to this one, for example, the second one, we tell the previous node to point to us, and we do that each time. So every time we move on to the next node, we gotta call on the previous node and tell it that the next node is set to the current node. Okay, so that's why we need previous node. All right, so back to the code. All right, and then the way I did it is originally I did it using 2 array lists for keeping track of the random pointers. So I'll let you think about that for a second. What I was trying to do, one would represent the from nodes, where the random pointer is pointing from, and the other one would be the to node, the one representing where the nodes are going to. But then I saw a much more efficient version of this, where the person used, I looked at one of the solutions, and the person used a hash table, and that made it a lot more efficient. And I'll show you guys the efficiency at the end, how fast it is using a hash table versus 2 array lists for the random pointers. So if we're using a hash table, we're just gonna create a new hash table. The types inside of it are going to be node. It's going to represent, but we're not going to, and what we're going to store in this hash table is actually for every, actually let me type this up and then I'll explain it. Okay, so the way we're going to use this table is for every original node, we're gonna have a reference to the new one. So we're going to create a new new one of these. Let me see. We're going to create a new. We're going to create a copy of this, and it's going to, and down here it's going to be, so for each one of these there's going to be a copy, right? And so for each key in the hash table, it's going to point to the equivalent new node, right? So I hope that makes sense. So that's the hash table. So this would be the key, not this way, and then this would be the value. All right, I hope that's clear. Back to the code. Okay, so I created a new hash table. Now let's iterate through the original linked list. The original linked list. And what we're going to do is, while the current node does not equal null, we're going to do the following. And also remember that we initially set the current node to the head. So this would be, so it's set to something. It's not set to null at the very beginning. We're going to create a new node that's going to represent the node in the new linked list, the cloned one, right? And node, oh, by the way, we haven't done node yet. Let me just copy over. Node is incredibly simple. So a single node just consists of a value, a next node, and a random node. And then there's only one constructor that takes in the value, sets the value, but leaves the other two to null. So we would have to set them manually if we wanted to change that. Okay, so node, new node equals node, new node equals new node. I know it's a little bit confusing. And then, can you guess what this part is? Well, it's going to be current node, that value, right? And then here, at this point, it would be a good idea to check if previous node is set, because if it's not set, can you guess what that means? I'm sorry if I confused you. Previous node, that is. So if previous node is not equal to null, then we are not on the first element, right? Where it's not the head element, because that means that we have already iterated, at least once. And let me put an else statement here. And the else part implies that we have that this is the beginning. This is the first time. This is the head. And in this case, we do copy head equals new head. Okay. Because this copy head, that's going to be the deep clone, the pointer that we will return at the end, because this is everything. This is what we want at the end. We just want the node that represents the new cloned linked list. And then if it's not the first node, then we want to set the previous node next to this new node. Okay. So far, so good. I hope you guys are following me and I'm not confusing you guys too much. And then finally, we need to do something in regards to the randomness, right? So let's work on randomness. So the new node's random. Okay, this part is interesting. The way I had to solve it, and this is the part that was confused. This is probably the most important part. How do you solve this with the randomness? So the way you're going to solve it is, so let's pick one that has a random value that's not null. So this one has a random value that's not null, and this one is pointing to 7, right? Right here. Oops. Right here. So 1 is pointing to 7. The last node is pointing to the first, so that's random. So the way to do that is the new node random is not going to point to the new node, new linked list, any of the nodes in the new linked list. It's going to point to the original node. So that means here what we're going to do is we're going to set it to current node dot random. I hope this makes sense. So we're going to have 2 of these, right? 2 of these lists, but initially the new list, the copy list, is going to point the random part, not the next part, not anything else. The only part that's going to point to the original list is the random part. Okay, and then what else? Then we do a map.put. We're going to put in the hash table, we're going to put in the current node and the new node. So we have a table of each, and I already went over this, so I'm not going to go over it again. But every node in the original linked list will be mapped to the new node. Okay, and then what else? Well, now we gotta set the previous node to new node. We gotta update previous node. So that happens no matter what. Whether it's the first time, if it's the head, or if it's down the road. This part we got to do. We got to update the previous node to the current node. And don't forget this part. I forgot this. Make sure to update current node and set it to the next element. Otherwise, this will loop forever, right? Okay, cool. So that's it for that. And then now we gotta take care of the random pointers, because remember, the random pointers are not working yet. Right now they're pointing to the original linked list, nodes in the original linked list, not the new one. So here, what we're gonna do is let's create a, let's call this new current. I switch over to underscore just because that's how I have it in my example code. But that's usually not a good thing. You should stay consistent. If you're using camel case, stick to camel casing. So anyway, so we're just going to start at the newly created linked list at the head. And what we're going to do is, while the new current is not equal to null, we're gonna do the following. First, we got to make sure that new current dot random is not null, meaning it's pointing to a node in the original linked list. Okay, if it's null, then we're good. And what we want to do is we want to say node. Let's just call this node. And it's going to be equal to map.get whatever the. So we have to get okay, so this is a little bit confusing. This might be confusing some of you. We're getting the node in the original linked list. We're getting the value of that. So the value is going to be the new node. So this is actually a new node. New current random points to an old node. But map.get will get the value of that old node, which represents a new node. So this is actually a new node. Maybe a better name would have been new node. But for now, I'm just going to call it node. Okay, and then what are we going to do with that? Well, we're going to say new current, because we're iterating through the new linked list, the copied one. We're going to say the random is equal to node. Okay, and finally, we're going to set new current equals to new current dot next. And that's so this does not go into infinity. This is just, okay, cool. So that's necessary. And then finally, we're just going to, let me see, let me make sure I put this in the right place. We got to return the head. Remember that, the copy, the newly created linked list, the head of it. Okay, and that should do it. And then finally, just to see the results, I'm just going to copy this part. I'm going to create a function that prints out the list. Okay, that part is just a simple iteration printing out the value, the next value, and the random value. Okay, and then if we run it, print list. Okay, I'm not sure if I have any issues. Yep, there's some issues. Hash table, it doesn't like hash table, first of all. So let's fix that real quick. And that's because in the solution, I should have imported everything. That's one issue. Is any copy head, it doesn't like copy head. because it's copy node. Oh yeah, I should have called this copy head. Yeah, let's try this again. New head on line 18. New node. I'm messing up on the names a little bit. All right. Okay, cool. So there it is. 7 is pointing to 13, 13 is to 11, 11 to 10, 10 to 1, and 1 to null. And then there's the random pointers, which I verified, and this looks correct. This matches this. And this is the copied version. I mean, obviously, this could have been easily the original. It's hard to see. It's hard to tell if that's the copied version of the original. But, yeah. Okay, so just one more thing. So when I did it with two linked lists for the random pointers, I would get a efficiency that looked like this. I was in the bottom 15%. I was doing work. So that's a pretty bad efficiency. The runtime was 37 milliseconds, and it was that's very low right here. And then space usage also not very good, 16.91. So this was not good. This one's definitely not a good solution. And then when I used the hash table, which I don't know why I didn't think of that right away. That's actually very obvious. The efficiency, look at that. The efficiency went to freaking 100%. And also my memory improved quite a bit. So that was actually pretty awesome to be able to do that. So, all right, guys. This is the challenge that I could not pass for the life of me, and made just a whole that part of the interview just incredibly awkward. But here you go. My loss is hopefully you'll gain, and hopefully you won't make the same mistake that I made. All right, guys. Please do me a favor, real quick. Can everybody just subscribe right now? That would be awesome. And all right, cool. With that said, good luck if you're interviewing with Amazon. Wish you the best. And if you have any questions, just feel free to reach out to me. All right, guys, take care. Bye.